Hello and welcome back. We're going to continue our exploration of integrals using inverse trig functions by considering the following problem. The integral of 1 over the quantity x minus 1 times the square root of x squared minus 2x with respect to x. And once again, we're not really sure which inverse trig function we're going to apply just yet because we have a square root, we've got some subtraction. It's unlikely it's going to be inverse tangent, so it's going to be probably sine or secant, but again, impossible to tell at this point in the problem. So just like before, we're going to use completing the square to rewrite this as something we can recognize. So to start off, we're going to complete the square in our denominator. So we got 1 over x minus 1, square root, save some room. We've got the x squared minus 2x already there. We're going to take half of the negative 2, which is negative 1, and square it, which is positive 1. And we're going to add and subtract that simultaneously so that we can keep the value of our integral the same. And then just like before, we're going to rewrite the first 3 terms as a perfect square and then have the other part left over. So this is going to be the integral of 1 over x minus 1 times the square root of x minus 1 squared minus 1 with respect to x. And it should be pretty obvious to us that we should pick u to be x minus 1 here. So we're going to let u equal x minus 1. So du dx equals 1. And so du and dx are the same. All right, so next up, let's go back and rewrite our integral. This is the integral of 1 over u times the square root of u squared minus 1 du. And this is just like our inverse secant integral. So this is going to be the inverse secant of u plus c. And then last step, replace the u. This is the secant inverse of x minus 1 plus the constant c. And depending on your applications, you may or may not need to use an absolute value on the x minus 1. But in any case, we would want to make sure that we're having consistent quantities with our square roots. So again, looking back at the original problem, complete the square, rewrite it, and then recognize it as one of our 3 important derivatives of inverse trig functions.